So in my time, my engineering maths was not that much strong. Okay, so this is an irreversible. Okay.
Okay, sir. Normal MTech coursework, mechanical interview. I did some big blunders, so I don't want to do that again.
So you are interested in IISc interview. That is perfectly fine. Okay, so we will start your IISc mock interview. Okay, yes. Tell me.
No, actually, the first interview that I gave for IISc MTech, that normal MTech coursework, mechanical interview, I did some big blunders, so I don't want to do that again. Therefore, this session.
So you gave. Okay, yes. So you gave IISc interview before.
Yes, that was for MTech coursework. Now I have
Okay,
IS research.
okay. I understood. Okay. So what do you want? Should I conduct a mock interview, and after that, I will. I mean, give you some suggestions over the interview.
Okay, sir. Yeah, that's fine.
Okay. So tell me your favorite subject.
The thermodynamics.
Thermodynamics.
Is there anything else I can help?
Okay. Thermodynamics. Fine. So first of all, Hark, you tell me that out of enthalpy and work, which is a thermodynamic property and why?
The enthalpy is a thermodynamic property, not work, because work is dependent on the path, but enthalpy depends only at a state. So it does.
Okay.
So the change does not depend upon the path taken for enthalpy.
Change does not depend upon the path taken on enthalpy. And what about entropy?
Entropy is also a property, and it only depends upon the final state and initial state.
Okay. So can you just write the expression of entropy for which it will be a property? Okay. I mean, so if you have a closed system, okay. So if you have a closed system, can you have some heat transfer or mass transfer?
For a closed system, there can be only heat transfer, no mass transfer.
For a closed system, there can be only heat transfer. Very good. Okay. So for a closed system, can you write the change? Can you write the expression of change of entropy?
Okay, sir. Yes, sir. I wrote ds equal to dq by t plus s gen. Do I show it?
Yes. Show me. ds equal to dq by t plus s gen. Okay. So now you tell me that s gen from where it comes? S gen from where it comes physically?
So this s gen is due to irreversibilities during a process.
Irreversibility is during a process.
Process.
Okay, fine. So have you heard about the TDS relationships?
Yes, I heard about it.
Okay. So if you have heard about the TDS relationship, then you tell me that the assumptions behind it.
Sir, for TDS, I don't think there are any assumptions. They are valid for all processes and for all substances.
For an irreversible path, will it be valid? For an irreversible path, will it be valid?
The TDS equations, sir, they will be valid because they are derived from first law, and first law is valid for all processes.
Okay, you show me. You take some 3-4 minutes and derive the TDS relationships.
Okay, sir.
Hmm.
I think it is valid only for reversible because I put dq as
What?
ts. I put
Okay.
dq as tds and
So you are saying that you are putting del Q as
del q as tds.
TDS. Okay. And this is valid for only reversible process. Right?
Yes, sir.
Are you sure? Okay. If you are sure,
No.
you
Okay, sir.
you are sure, right?
Yes, I am sure dq is on
Okay.
ds only for.
Okay, fine. So this kind of formula you do have, right? dH minus
Yes, sir.
dP, right?
Yes, sir.
Okay.
Yes, sir.
So you are saying that these TDS, relationships are only valid for the reversible ones, right? Reversible processes. Okay. You are saying this, right?
Yeah, after deriving. Yeah.
Okay. So if that is so, so then you tell me that if in the thermodynamic plane, so let us say that I have any plane, maybe a PV plane. So if I have two points, 1 and 2, okay. So now I am connecting them with an irreversible path. So this is a path. Let me call with A. Okay, so this is an irreversible. Okay.
Okay, sir.
Okay. So now you tell me that how you can calculate the entropy change from 1 to 2. And for these 2 points, you know everything, every property. Like, other than obviously, other than entropy, you know every property like temperature, pressure, volume, anything. But you don't know entropy. So you have to here, calculate the change in entropy if this is the irreversible path. And what do you know? T1, V1, and T1, and here P2, V2, and T2. This you know. So now you have to calculate the change in entropy for this irreversible path. So you have to find what? You have to find del S 1 to 2. Okay, this you have to find change in entropy for 1 to 2, and this is an irreversible path.
So for irreverse, sir, del S will be same if it is reversible or irreversible. Like
Del S will be same
since it's a property. So sir,
since it's a property. Good,
property.
very good. Okay, very
So I
good.
will assume the path to be reversible and then just use my
Use what?
TDS equations, and I'll integrate it, and then I'll
Very good.
find the value of variance, and that will be.
Very good. That was the concept that I wanted to hear, that this equation is applicable. This equation is actually derived from the concept of the reversible process, but it is applicable for any path because ultimately it will give the entropy change, which is not actually a path function, right?
Yes.
Okay, fine. So now, okay, fine. So consider that you have a bulb. Okay. So you have a bulb. Okay. So I know that the bulb is looking, horrible, very bad drawing. So you have a bulb which is connected to the uh, battery. Okay. Or any, any electrical connection. Okay. So for this bulb, how can you define the thermal efficiency or the first law efficiency for this bulb? How can you define that?
So it is bulb.
Yeah, this is a bulb.
Okay. 1 minute. Efficiency.
So yes, you have to define the first law efficiency. Okay, so eta 1, I'm telling the first law efficiency.
It's the work output by output by input. First efficiency was
So for this case, what is the output?
so I think the light energy, because
Light
that is what
energy.
we
Very good. Very good.
using.
And what is the input?
So the electric current, the power VI, that will be
Okay.
the
Fine.
input.
Okay. Very good. So now you tell me that what is the second law efficiency of this?
The second law efficiency was it was the actual amount of work. So for this bulk case, so we can write the second law efficiency as the actual, the energy that the light it is releasing in actual, and so divided by the maximum possible energy that it can release if everything was going according to everything was reversible, no losses. I think that was it.
You are thinking in the right direction. So okay. So first of all, if I tell you to give me the definition of the second law, I mean efficiency. So give me the definition. I mean,
The
if you
second
have
law
something to
efficiency was
say, say, say.
actual work by maximum possible useful work.
Actual work by maximum possible useful work. Okay. So okay. You take this I mean definition only, and after that you tell me that what is the I mean second law efficiency for this part.
Actual work by maximum possible useful work.
Hmm.
But for this bulb isn't doing any thermodynamic work, but
Hmm.
it is will be zero.
Exactly, it will be zero because it is not doing any thermodynamic work. The heat energy is being released. Okay. Okay.
Only hidden as release.
Exactly. So one final
The
question I will
first
ask. Mhm. Yes,
the,
yes.
the
Tell
first
me.
the first law efficiency will be zero also, or it will be different.
No. The first law efficiency will not be zero. That actually you have told it. I mean correctly. The light energy and heat energy that it is giving us by
Yeah.
the electrical energy.
Okay.
Okay.
The output by input, so that will remain same.
Exactly. That will remain same. Okay. So one final question that I will ask you. Okay. So you have okay. You have uh insulated you have an insulated chamber, and there you have two partitions. Two partitions. Okay.
Yes, sir. Okay, sir.
So so you take the partitions as 1, 2, and 3. So here you have P1, V1, and T1, P2, V2, T2, and P3, V3, T3. Okay.
Okay, sir.
So now what I have done is I have ruptured all these membranes simultaneously. All these membranes simultaneously. Then you have to find the final P, V, and T. How can you find? Take some time until.
Uh, so we can assume it to be ideal gas.
Yes, you can assume it to be ideal case of this.
And so all three are same ideal gas? No.
Okay. All three are same ideal case. Okay. Hark, you don't have to, find the final answer. You can just also tell me the process also.
The process that I'm doing. Sir, so I wrote the first law like Q equal to U plus W. And sir, W will be 0 because there is no thermodynamic work. And sir, Q will be 0 because it is insulated. So the del U.
So first of all, what
the
is your
U-
control volume here? What is your control volume here?
Sir, the control volume is the whole, like all three partitions, 1 plus 2 plus 3. I'm taking.
I mean, if is this your control volume and this this
No,
three?
sir, it's the amalgamation of all three of them. Yes, sir. This is the control volume.
Okay. Okay. So this is your control volume. Okay. Okay.
Yes, sir.
Continuing. So you are writing the first law. Q equal to U plus
I mean, del Q equal to
yes. Del Q equal to
del Q equal to du plus del W. And sir, I put del Q as 0 since there is no heat interaction.
Very good.
And sir, no thermodynamic work is also being done. So
Okay.
del W will also be 0. So du will be 0, which will imply that U1 will be equal to U2. The U1 the U1 is the
Okay.
initial step of all three of them combined, and U2 will be after mixing.
Mhm.
After mixing, so I wrote U1 as CvT1 plus CvT2 plus CvT3 since all three of them are ideal gases as per our assumptions.
Okay.
And then the U2.
So first of all, you are writing CV T1
T1 plus
T2
T2 plus
Okay.
CvT3.
But
And
this is actually small u1, but you cannot write small u1, right? You have to find the capital U.
Oh, exactly. This is yes. Then sir, I will use the ideal gas law, PV equal to MRT. And sir, I'll find the mass from PV by RT. PV by RT. Then I'll multiply individual P1, P1.
How can you find the mass? How can you find the mass?
PV by RT. Ideal gas equation is PV equal to MRT.
Okay. So in the ideal gas equation, PV equal to MRT, I mean, what is that R? What is that R? What is the value of that R?
So PV equal to PV equal to MRT, the R is the universal gas constant divided by molar mass.
Divided by molar mass. Okay, fine. Okay, good. Are you sure?
V1 by
Divided by molar mass, is it?
Sir, this is a universal gas constant divided by molar mass only. Because sir, the normal equation was PV equal to nRT. So when we divided the molar mass, then N by M becomes M. Oh wait. So
N by M?
1 second. 1 second. So sorry, we are multiplying it by molar mass. And
Is one, right?
we divide.
I have written.
Yeah, yeah.
Right. So this is R bar. This R. Fine. Okay. So lastly, you can find here M1, M2, and M3. Right?
Yes.
And for the final case, what you will write?
For final case, I'll write M1 plus M2 plus M3 into CV TF. TF will be the T final.
CV T. Right?
Yes, sir.
Okay. Fine. Very good. So one last question, that now for this case, you have a gas. Okay. So this gas is a fuel. Maybe you have the methane plus oxygen, and somehow you gave it some energy. Okay. From where you gave the energy, that is not important here, but still, so from that moment, now it is insulated on. Okay.
Yes, sir.
So you have to write the first law for this combustion process, happening in this chamber. You got my question that you are having a mixture of CH4 and O2. Okay. After that, they are burnt. Okay. Now, from the moment they are burnt, you will consider the chamber to be fully insulated.
Okay, sir. Understood.
Now you have to write the first law for this gas. For this gas. After it is being burnt. First you write the first law.
So the chemical energy of the fuel, that CH that's plus O2. So after it is burned, the chemical energy will be used to increase the temperature of the system. So the chemical energy will be equivalent to the thermal energy for a closed system, assuming no losses.
Okay. Good. Good. Okay, so what was your BTech project?
So our BTech project was, I made a automatic water distribution chamber which distributes water to various lands depending on the moisture content of the soil.
Automatic water chamber which distributed, which distributes
Which
water
channels
to-
waters to the required area depending upon the moisture content level of the soil to make irrigation more efficient.
Okay. Okay. So, give me some more insight that how did you make it, or how did you design?
I used a microcontroller to pull out data from various moisture sensors, and sir, after it and so there was this chamber which rotates using a servo motor, and so the rotation is calculated by how much each moisture sensor data is feeding. So if moisture sensor 1 needs if moisture sensor 1 is showing that the moisture content is low, so it will rotate by a specific degree by like let's say theta 1. And so when it rotates, there is the chamber is basically two cylinder concentric cylinders. The outside cylinder have many holes and the inside cylinder have only one hole. So as it rotates, it meshes with any specific holes, and so through that the water flows and
Okay.
reaches.
Okay. So, which kind of controller did you use to
I
uh,
Arduino Uno.
yes.
I used Arduino to control the flow rotation.
Okay. And what will be the effect of temperature here? If I increase the temperature, what will be the moisture, uh, quantity, and how can, so what I am trying to ask is that much precise that if I increase the temperature, the moisture control can vary? Okay. So there are some,
It can.
yeah. So there are some countries where the moisture can vary throughout the day. Okay. So there, can it take that, variation, quickly?
So we will have to uh, so for a specific area, for a specific region, we will have to write the codes in such a way, and the boundary parameter should be defined according to the region, because some region have the moisture sensor basically it measures the resistance between two electrodes.
Okay.
So with increase in temperature, it might also change.
Okay, fine. Okay, so your interview is over here. Now I will give you the feedback and suggestion. So first of all, I would like to tell you that your thermodynamics, fundamentals are actually very good. And the last two questions that I asked you, like this gas chamber and those, partition. those were almost the exact question which I was asked during my MS interview. So you are going for an MS interview, right, in IISc?
Yes, I am.
So, so these were the exact question that I was also asked. Okay. So the thing is, be confident. Okay. They will not ask very hard. Okay. They will not ask something like very hard or very unnatural. No. They will ask the same questions that you have solved only for GATE and you have solved in your from your books also. Okay. But there is a catch that you have done it very well. That is, you have to, see, in all the cases, people think that I know the formula, I can apply that. Okay. Like, I'm sure that 99% of the students will make that mistake that you also, make it first. So that TDS formula. Okay. So that TDS formula, maximum people, they they don't care that this formula is, derived from the some assumptions. Some assumptions are there. So you also miss that, right? But after that, you caught that. That is perfectly fine. So your approach should be that the same question that you have solved for your GATE only, that you have solved from the conventional books, but the same questions you have to solve like a very logical thing. If you are applying any formula, you have to be very clear that why I am applying that formula. Okay. Have you understood?
Okay.
So this is the only thing. This is the only thing that you need to take care of. Be it any subject, thermodynamics, fluid mechanics, doesn't matter. But you should be knowing each and every assumption, each and every, uh, I mean, logical part of every formula. If you are applying any formula, they are going to ask you that,
Yes,
that why are you using this formula. So that is the only thing that you need to take care of. Other than that, everything is fine. So first, let me just uh off. So I will stop sharing here. Okay. So okay. So other than that, one more thing that from your BTech project, I don't have much time here left. Okay, only I have 5 minutes more. So that is why I have not asked so many questions from your BTech project. And they will also not ask, so many questions. Okay. But you have to know every why, how, and what you have done. Like, so they will ask you that why you have, why you have designed such a controller? Why you have designed? So they can ask you something like, so from your BTech project, you have to be very, logical. That if you have done each and every step, so then why you have done? Okay. So they can ask you that what is the general speed of that that thing, that the general speed of that, or what is the general flow rate of the water that you have used. Okay, and why you have used that. So everything from your BTech project, why you have used that and how you have done that. Okay. So finally, we have almost 5 minutes, 5 minutes and 30 seconds. I will ask you one or two more questions from engineering maths. So before that, if you have any question.
Sir, do I need to prepare heat transfer also, or like, because
No, see. They will generally ask you to tell only one subject. Only one subject. Okay. So if you tell thermodynamics, they will ask only thermodynamics. And I think there will be a meeting also before the interview happens. The at least the mechanical engineering department from IISc, in my time, they actually conducted a meeting. Okay. That means, and they will explain everything, that how many how many subjects they will ask. So they generally ask only one subject. So in my time, I actually offered them that I like both fluid mechanics and thermodynamics. So you can ask me anything. Then they told me, no, you have to tell me only one subject. Okay. So you can prepare heat transfer. So, but whatever you like. Okay.
I think I will brush off my thermodynamics topics better. That will be more
Okay.
beneficial.
Yes. So actually, the level of the question that I asked you, that is the only. this is the same level that they will ask you. Okay, but if you want in the next mock interview, if you want to schedule with me, then I can ask you some advanced some advanced question. Okay, so these were actually very basic question, and these are actually very good. I mean, your level of knowledge is actually good, but if you want, then in the next interview you can make me remind that in the previous interview you have already asked me the fundamental questions. Now I can go for the advanced level. So I can ask you some advanced level thermodynamics question. Okay.
Okay, sir. Okay.
Okay. So I have 3 minutes left. So before ending me, let me tell you, they will ask you some questions from engineering maths also.
Yes, sir.
Okay. So and
I only know
take
linear
this
algebra.
comfortably. Yes, you can tell them that, sir, I am comfortable with the linear algebra part. So they will ask you from that part on. So in my time, my engineering maths was not that much strong. So I told them, sir, you can ask me from anywhere because everything is same for me. So then they asked me this, that can I ask you from linear algebra? So then they asked me also from linear algebra. Okay, so I have 2 minutes. So I will ask you one question from linear algebra. Okay. Okay, you don't have to write anything. You can just answer here. Okay. So you tell me that what do you mean by a diagonalization of a matrix?
Diagonalization of matrix. So we basically convert a matrix into three matrices. The first one will be the eigenvectors matrix. The second will be the diagonal matrix of the eigenvalues. So in the diagonal elements will be eigenvalues, and the third will be the inverse of the eigenvector matrix. It is pretty useful when we need to find the high powers
Very good.
of.
Okay, very good. Now you tell me that is every matrix diagonalizable?
No, sir. Every matrix is not diagonalizable.
So how can we
Only
find that if the matrix is diagonalizable or not?
if they have distinct eigenvalues and eigenvectors, then only it is diagonalizable.
Okay, then only it is diagonalizable. Distinct. So how and so will every matrix will have distinct eigenvalues? So I mean, how can you find that if it is having distinct eigenvalues or not?
So we will use a minus lambda I equal to 0, and we will find eigenvalues for and
Okay. So can you write for every matrix that that equation that is the determinant of a minus lambda equal to 0? Can you write this equation for every matrix?
no, sir, only when a lambda I is singular, then only we can write.
Lambda is singular.
From there we derive a minus I equal to 0.
Okay, so the meeting will almost end. So here I will end the meeting. Okay. So in the next interview, I will ask more questions from engineering. Okay. So you just brush up your knowledge in engineering maths. Okay. You have a good knowledge, but still. Okay.
Okay, sir.
And lastly,
Okay,
can you have enjoyed the meeting? So if you have enjoyed the meeting, so it will be very good for me that if you can leave a comment on YouTube or LinkedIn. Okay. If you have enjoyed, obviously,
Okay.
there is no such. Okay.
Okay.
So I will meet you in the next meeting and all the best. Okay.
Thank you, sir. Thank you, sir.
Okay.